welcome all for joining us in today's webinar titled Fixing the Internet Routing Security Problem. I'm Anosh and I work in the Academy team at APNIC. It's great to have Aftab Siddiqui here from the Internet Society to present this webinar. Aftab is a Senior Internet Technology Manager at ISOC. In terms of housekeeping, given that we've had over 290 registrations for the event, we may not be able to answer all your questions, but we'll do our best to try. We'll have a Q&A session at the end. Feel free to type up your questions in the Q&A box below. You can also email us after the event if you have any more questions. The recording of this webinar will be emailed to you shortly after the event. I'll now hand over to Aftab to start the webinar.
Hello, everyone. I have Aftab Siddiqui here. I hope you can see me. I would like to keep my video on just because you can see who is talking. It's not coming out from your computer magically. Thank you all for joining. I'm not sure which part of the world you are in. 290 people, that's a very nice number. So let's see if we can make this session interactive. Anytime if you feel you need to ask something, just make sure you just ask in either Q&A or in chat anyway. I'll try to look at it as much as possible and try to answer it as well. So without any further ado, we can start. So what we are talking about today, let's get into the detail first. Right. So first, we need to understand the problem, what the problem is, some key topics such as BGP hijacks, leaks, spoofing, and we can offer any solution for that. We'll talk about MANRS. Of course, if you can see my video, you can see at the back, there's a big banner in my room. So we'll be talking about MANRS as well. So let's discuss the problem. Okay, routing incidents are increasing. If you've been part of this community, if you're part of the internet ecosystem, you know there are issues, and the issues pop up every now and then. And of course, we'll be talking about those issues, what those issues are. But just for the sake of numbers, in just 2019, around 1,800 BGP hijacks were recorded by BGPstream. BGPstream.com is a service, a public service provided by a company called BGP Mon, which is now owned by Cisco. But still, BGPstream.com is available for publicly available. You can see what's happening on the internet on a day-to-day basis. These hijacks led to multiple problems. It could be loss of revenue, reputational damage, and etc. Most of the incidents are only for few minutes to few hours, but sometimes we have seen it. They're not. I mean, they're rare, but sometimes they goes up to many hours. It can have a global consequence. It can have a very regional impact, or maybe you don't feel it. You don't feel it doesn't mean it's not happening. It causes real problem, as I said. It can hijack your traffic. Then it means it can reroute your private information or financial information or things like that. And we'll talk about it, that how does it work. Before going into details, first thing first, we need to work out how routing works. I mean, if you recently looked at the internet routing table, we have around 68,000 networks in the internet routing table. When we say networks, it means the autonomous system numbers. And that is part of the whole internet routing table. Routers use BGP. BGP is a border gateway protocol. It exchanges the reachability information, networks they know, and how to reach. Routers build a routing table and pick the best route when sending a packet, typically based on the shortest path. And just going into further details, what is the role of a router? Very simple. It finds a path, forwards the packet, keep on forwarding the packet until something breaks. And if something breaks, it finds an alternate path, and then keep on sending the packet on the alternate path. And it keep on doing it until you turn it off or do something wrong with it, right? And we'll be talking about something wrong with it mostly. And there's another term you hear most of the time is called forwarding. The difference between routing and forwarding, routing, it builds a map and gives you the direction. Forwarding is actually moving packets between interface according to the direction. So just to be clear, when we say routing and when we say forwarding, okay? So a lot of people sometimes use this term interchangeably, but just to be clear, this is the difference between them. Right. So as I give you the example of internet routing table, the current size, which I just looked up this morning, it's 8,322,782. I mean, if you look at the graph, it's increasing exponentially. Few months ago, we were just talking about if it's going to reach 800,000. Well, it already crossed 800,000. Another problem is probably you look at your routing table right now and you say, oh, no, I don't have 800,000 routes in my routing table. I have less, or maybe I have 850,000 routes in my routing table. The routing table is is dependent on from where you are looking at it. So this data is from the CIDR report, which is run by Jeff Houston and Philip Smith. And they have two vantage points. One is in Japan and one in Australia. So you can say it's roughly around there is 800,000 prefixes in the internet routing table. And if you go to the unique ASs, just when last year I was giving a presentation, and I updated the record, and it was around 63,000. And today, when I looked it up, it was 68,000. So the increase is still exponential, just like the prefixes. And if you go back onto this one, this is only V4. So if you add V6, then you can add more on top of it. Unique ASs, 68,000. Number of ASs announcing only one prefix is 24,000. Why it is important? We'll come back to that one, that why it is important. Right, as I said, internet literally runs on one protocol, that is BGP, Border Gateway Protocol. It is based on entirely on trust. No built-in validation that updates the legitimacy. And the chain of trust spans on continent. It's not just like if I'm sitting in Australia, I'm not just talking to people in Australia, I'm talking to every person on the internet. So that means I have to connect with everyone. And that means the trust has to be on multiple contents, not just between myself and the peers within Australia. So it's a big chunk. And when the only protocol you have to run the internet is based on trust, what happens is this. So it's from the last year's the top headline: the AWS traffic hijack used sent to phishing site into our cryptocurrency Heist. So what happened was somebody quite elaborately hijacked AWS DNS service called Route 53, and they redirected all the traffic towards a malicious website for Ether wallet. And they created a fake page, and people end up putting up, at that time it was Bitcoin boom. So everybody was using Ether wallet at that time. I don't think many people do these days, but it was quite common at that time. And all of a sudden, people lost more than $150,000 within 2 hours. And if you go to the lower slide, headlines: Russian telco hijacked internet traffic. I mean, what happened was they end up announcing more than some, depending upon which report you look at, more than 80,000 or something routes, which redirected a lot of traffic from different places towards them. And it lasted for not for very long. It was a few minutes, but it ended up creating a lot of problems for companies like Google, Amazon, Facebook, Cloudflare, and of course, you couldn't access these websites. So what are the threats you're talking about? As I said in the beginning, number one is prefix or route hijack. People say prefix hijack, route hijack, BGP hijack, all are same. It's just an hijack. Then it is a route leak, or we call it BGP leak, prefix leak, anything, and IP address spoofing. So all the incidents you see on the internet right now are a combination of all of three of them, right? So we'll be discussing all three in detail. So you don't have to read all the content written on the slide deck. So moving on to what type of networks are there, right? So AS types. So either you are a stub. A stub means you are the only network. Like my home network is a stub network. I have my own ASN, but I don't have any other. I'm not providing any services to anybody else. All the services at my home are my services. I'm personally using all those IP addresses. I'm not giving it to my neighbors or as a service. So I'm a stub. My ASN is the last one in the announcement table. So that's the stub network. Multi-homed, if I have only one ISP, if I'm connected to two ISPs, then I'll become multi-home. Transit, if I have, if you are part of an ISP, of course, my ISP is my transit. So I am connected to a transit provider. And of course, then they are connecting me to the internet. Then the internet exchange point. I hope almost all countries in the Asia Pacific region have internet exchange points, and probably your ISP is already connected to one of them. If not, then it should be. But internet exchange point is is usually within the country. It's a switch where all the ISPs or the enterprise, anyone with their own ASN, can connect and share traffic locally. It shouldn't. If I need to talk to somebody in Sydney or Melbourne or Brisbane, I shouldn't be leaving Australia at all. Number one, it is expensive, and then it also added delay. So this is how you can be connected in 4 different manners. So as I said, you are getting BGP from the transit. Let's say I am the customer. I am taking BGP feed from my ISP, connects you to the rest of the internet. Either I can take full BGP routing table, or I can just be on default route. I don't have a big enough router at the moment to take the full routing table, so I take selective. It's not a default route, but I do selective routes on the basis of community. I mean, we will be talking about BGP communities in another webinar which APNIC is conducting, so make sure you attend that one if you're interested in how you can take selective routes from the BGP. And I'm announcing my prefixes to, well, I have only one prefix, so I'm announcing my prefix to my transit provider, and they are taking it to the internet. So you are an ISP, so you have customers like me, right? So downstream, I'm below the transit provider. So you connect them to the internet, you give them either full BGP feed, or you just give them default route. I'm not the only customer. You could have multiple customers, of course, and you receive routes from all of them, right? And then you send it to the internet. You are directly pairing with someone. Let's say I am an ISP and I have another ISP across the road, and I said, well, why don't we connect to each other? Probably we have some traffic to share between us. So that could be something interesting. And we can start sharing data with each other. I mean, we shouldn't be sending any traffic to our transit provider if we are only sharing data between each other. So that is a pair. Right, sorry. And the last one is you're pairing with an IXP, right? Even in the previous example, you can peer you can directly peer with other members of the IXP, but in this example, you are actually peering with the route server. What route server is, you just peer with the route server and everybody else peers with the route server, and you get the routes from all the peers rather than connecting to each one of them individually. But of course, then you are relying on the route server. We are not again going into detail of how route server works. That will again be covered in the webinar from APNIC. So now let's talk about the hijack. Right? Just look at the diagram closely. It will explain how this works. As I said, it is prefix hijack, route hijack, or a BGP hijack, all same. What happens is that you are talking to, let's say, ASA, right? And that traffic is going there without any problem. It's coming from ASA, and you are talking to the ASA without any problem. And all of a sudden, an ASX pops up in the internet routing table and start announcing the same prefix which you are announcing, right? Same prefix. So you are announcing 192.0.2.0/24. They started announcing the same prefix. What happened is, if you look at the diagram, I mean, BGP works on the shortest path. So what will happen is some of the traffic will start going to ASX, right, rather than coming to you. So it will be a hijack. Another scenario is that you are announcing 192.0.2.0/23, right? And the hijacker start announcing a /24, and we know that it depends upon the length of your announcement. So if it's the /24, of course, this will be preferred. So all the traffic, irrespective of the shortest path or the longest path, all the traffic for that /24 will start going to the attacker, right? And it will not come to you. So that is a problem. If you look at the example, I mean, it happened in 2008, the most famous one. I mean, people still give examples of that even after 12 years, when the largest ISP in Pakistan, called PTCL, accidentally hijacked YouTube while they were trying to block YouTube in Pakistan. And we'll discuss about it, that how it happened and what they could have done. But this is a very famous example. And another example from yesterday. If you look at this, this information has been taken from the bgpstream.com. You can look up yourself. A ISP hijacked a prefix from a company called Boho Beach Club, and they started announcing. So the expected announcement was /22, and what happened that somebody else started announcing a /24, a specific /24, and that somebody was Gigabit Bank Global in Hong Kong. So this was a hijack. I mean, and it was, of course, if you look at the details, it was global impacting, because they started announcing a /24, and the actual prefix owner was announcing a /22. So they must have got the traffic from the Boho Beach Club, and of course that's how hijack happened. Route leak. So route leak is quite it's a bit of a it's a bit complex, right? So you need to understand one thing. Again, if you look at the diagram, so the green path is the normal path, right? So AS64502 is the customer. It was going to Google. But what happened is that all of a sudden, your peer, which is another customer of a ISP, started announcing Google prefix, saying that, oh, you can reach Google through me as well. So what happened is all of a sudden the traffic started moving from rather than directly going to Google, it starts going through another ISP, which is not it, which shouldn't have happened, but the traffic started moving from this direction, and now it is not clear that it was just a mistake, or they were trying to hijack the traffic, or something else, right? Even if it is a mistake, the customer cannot have enough capacity like the way you have it with your ISP or their upstream. So what will happen eventually, that there will be a bottleneck, and because of that bottleneck, the traffic will start dropping, right? And you won't be able to access Google, and that is the only path you have from at the moment, and it will start causing problem for you. You will not be able to access Google. So it's not like they are hijacking Google itself, but the path they have given you is so suboptimal that literally you can't access anything. So it is for you, it's a denial of service. Again, a very famous example in 2015, Malaysia Telecom and Level 3, a major backbone provider. Telecom Malaysia told one of the Level 3 network that it was capable of delivering traffic to anywhere on the world. So what they did is they started leaking the whole internet routing table through Level 3, which caused a massive outage for everyone. And quite recently, we saw the headline I gave you from the Russian ISP. So other ISPs start leaking the prefixes as well. So it created a massive problem rather just one ISP hijacking it. Again, a quick example from yesterday. It's one of the ISP Star Hub in Singapore. It's started leaking prefixes from Malaysia. So the leak prefix was 103.99.51.0/24, leaked by AS4657. I mean, you can see the details. Usually, the internet. And what happened for that moment, that traffic going to the Malaysian ISP or the enterprise, it started going through Singapore. Now, the third problem is the IP address spoofing. IP address spoofing is not new. It's been there for a very long time. A very famous RFC for that is also we're going to talk about at the end. It's called BCP38. What happens is it's very simple. I can give you a very simple analogy for that. Is if somebody gives you a missed call, what happens is you pick up the phone, you look up their number, and then you just give them a call back, right? Simple as that. But what happened if you get a missed call and then you pick up your phone and you see a number and you call back that number, and the person said, "No, I never called you." And said, "No, but I do have a missed call from your number." What happened all of a sudden that somebody spoofed their number and called you. If that somebody start doing that 10 times a day, what you will do is you will start sending a call back 10 times a day and saying, "Oh, you gave me a call." And if you multiply that effect 10,000 times, the poor person will start getting 10,000 calls without giving call to anyone. And that's what address spoofing is. You change the source address of the packet, because packet has source and destination. The destination remains the same, but what you do is you change the source address. But once the packet reaches the destination, it will be reversed, right? So the source becomes the destination and the destination becomes the source. Because source was spoofed, it will never reach the same, the actual source which initiated the packet. It will go to somewhere else. If you look at this example, it works like that, right? So simple as impersonation. What you are saying that you spoof somebody's source IP address and you send the packet, and what you do, and the person says, "Oh, my partner sent me a packet, I'll process this." Why? Because you were trusting your partner. you knew that if a packet comes from that partner, it's okay to open that one. But it was coming from a malicious host, so you shouldn't have trusted. But you saw the source IP address, you said, okay, fine, I'll open up. Similarly, if you see an email coming in from some of your family members or a friend, all of a sudden you open it up. But if it is coming in from a stranger, then of course you open up with the caution, or you say, I don't know this person, I'm not going to open up. Or, I mean, email systems are very, very good now. These days, they can easily pick up if it's not coming from the intended, if not coming from the right source. Right. So another one is the reflection attack. Can everybody see the slides, or something wrong with the slides? I just saw a message saying I lost slides. All good. Okay, sorry. So this is the reflection. As I was giving you the example saying, if the phone call incidents start happening 10,000 times a day, then it will create a problem. So what happens is in a reflection attack, and you have heard reflection attack a lot of times, either it is DNS reflection attack, the destination is for the reflector. And what happens is you do it hundreds and thousands of times, and you do it through bots. But all of a sudden, the reply comes to one person, right? So that one person never actually sent anything out, but the replies are coming back. And in the picture, it says, oops, a lot of replies without any request. I never sent any request, but the replies are coming back to me for no reason. So if you have an open resolver in your network, open resolver, what will do is they will send, somebody will start sending spoof DNS queries to all these open resolvers, and all these open resolvers will start sending responses back to one person or one entity or one host. And that host will be overwhelmed with so much traffic because number one, they never requested for it. Number two, there's too much that they can't handle it. And that is how denial of service happens. Only one, it is one of the use cases. Then you should make sure that your network is implementing anti-spoofing. How you do that, we'll discuss it. So there is a organization called CAIDA, C-A-I-D-A. They have a project called Spoofer Project. So they measure anti-spoofing data from all across the globe. How it works is you have to install a small software in your laptop and you run, because it has to happen from inside the network. I cannot measure anti-spoofing or spoofing from the internet routing table or from the internet. So I have to go inside your network to check if your network is allowing spoof packets or not. So you have to run a software, small software. It will start sending packets to a particular destination, a spoofer project server with different source IP addresses. Of course, because the destination is same, you'll receive all the packets. But if the source address is changing with every packet and you don't have any restriction in your network, the spoofer project will receive all the packets. If you have some kind of source address validation inside your network, then of course they will not be able to receive the packets, right? If they don't receive it, of course they will mark it. So this is the map on their website. The website link is given at the bottom. You can have a look as well from whichever country you are in. So a lot of countries are marked as green, right? It doesn't mean that they don't do, I mean, there's no spoofing happening from these countries. It means they don't have enough data as compared to the number of networks in that country to say they are, the whole country is doing something wrong. So I mean, it's a nice graph, but it's not very accurate in that manner. So the coloring doesn't show you exact picture. So that's why you have this table. So in the order, people have tested a lot from Brazil, USA, from Netherlands, India. And if you look at the number of ASN, only 26 ASN from Brazil, 96 from USA, 21 from Netherlands. So not a lot of testing has been done. So I assume, I mean, we have around 290 participants for this webinar. I'm not sure how many online at the moment, but if you haven't tested your network before, if you're not running, if you're not part of ISP, you're just a enterprise, that doesn't matter. You can still test it. Download the software, go to the Spoofer project website. The link was in the previous slide. Download it and run that. It will only take few minutes. You can just remove it afterwards, right? And the data will be updated on this website. So this is the picture from Australia, right? So the session, I mean, somebody tested it this morning. It is showing the timestamp, 28th of April. A lot of people tested it on 27th. So these are the data. If you look at the right four columns, it says if it was blocked or it was received. So luckily, all of them were blocked, right? If it was received, then it will be marked as red, just like this one. So I picked up a received request. So what happens is the spoofer program will start sending packets with different source IP addresses from your neighboring networks. Let's say your announcement is 43 to 47 126.0/24. So it will not only start taking source from the same network, but from a /22, from a /24, from other /24 up to /11, right? So it will start sending packet with that many source addresses. Right. So you heard all the problems, right? So number one is BGP hijack, route hijack, or prefix hijack, and then BGP leak, route leak, prefix leak, same thing. And the last one is the anti-spoofing or the spoofing attacks. So there are any tools to help you mitigate these problems? Yes. Prefix and AS path filtering, most importantly, RPKI and IRR toolsets. BGP Q3, touch base on that one. BGP SEC is also a standard. Unfortunately, nobody's using it, and because it requires a lot of changes in the BGP protocol itself, but not enough deployment and the lack of reliable data. And I said, because it is the internet is a collection of networks. Everybody is connected to each other. I mean, if you are not directly connected to every one of the other 68,000 networks, you are connecting to networks which are actually eventually connecting to the other network. So it is just a connection of different networks. Right. So if I need to solve a problem, it's not like I can solve the problem individually. All of us, we have to solve this problem together. It's ideally 68,000 networks should be solving this problem together, but if it's not 68,000, probably a big chunk has to do it. So one of the solution, I wouldn't say the only solution, but one of the best solution, because that is working really fine so far. Because number one, it is technology agnostic. It is not saying to buy this hardware or deploy the software. It is about the protocols. And that's why we say it's a technology agnostic. So it is called MANRS. Whether you want to pronounce it, I mean, you can pronounce it in whichever way you want, but MANRS sound good. So it is mutually agreed norms for routing security. What it does is it gives you certain actions, right? And those certain actions can be implemented in whichever form you want. For example, this slide. Okay. So these are the actions, right? Filtering, anti-spoofing, coordination, and global validation, right? Sounds very simple, and actually they are very simple to implement as well. So when MANRS started in late 2014, early 2015, MANRS was only targeting ISPs, right? So it is for the network operators, and they were only doing it. The focus was ISP, right? But when we started this initiative, after a couple of years, we realized that there are other building blocks in the whole internet ecosystem. And one of the building block is IXPs. So then we started a program for the IXPs in 2018. But the underlying actions remains the same. And last month, we also launched a program for CDN and cloud providers, right? And now we have 3 programs. If you go to manrs.org, manrs.org, you can see all 3 programs and their details as well. But the essence of all 3 programs remains the same. You need to filter, you need to implement anti-spoofing measures, you have to have your coordination in place, and you have to do global validation. If you look at the coloring, the color of anti-spoofing is white, remaining blue, because anti-spoofing is not mandatory. There are certain reasons because of that. We would like everyone to implement anti-spoofing, but there are certain problems which we're going to talk about. Limitation, I wouldn't say problem, which because of that, big operators are reluctant to implement blanket anti-spoofing measures. So we'll talk about all these actions in details now. Number 1 is filtering, right? So thankfully, filtering, as we said, MANRS is not about particular network operating system or particular vendor. It's about technology and open standards. So the filtering we talk about are actually covered in one of the RFC, which is RFC 74554, which has a BCP status, which is BCP 194. The title for that BCP is BGP Operations and Security, and it talks about the filtering, BGP filtering in detail. Why filtering? Well, that is your first line of defense, right? So in your house, in your apartment, you have the main gate. That is your first line of support. You probably you have a peek hole in your door, or maybe a video doorbell, which you can see who's out there, and maybe you ask who's out there before you open up the door. You just do not open up your door for anyone knocking on your door, right? You usually ask who's there. So that's your first line of defense. You control what you're announcing, and you control what's coming in. So not only in the house, you don't actually control who's leaving the house. That would be interesting. But in a BGP scenario, you actually have to control what you are announcing and what you are accepting. To avoid issues, you have to decide what to accept from other networks and make sure you only announce what you are allowed to. So the BCP 194 also talks about other things to protect BGP, such as TTL. But for this webinar, we'll be only talking about the prefix filtering. But if you want to read about it, so I have just highlighted this here, you can do that. So the prefix filtering, most important thing. How BGP works, what you do is you receive an ASN and an IP prefix from your RIR. Who is your RIR in the Asia Pacific region? That is APNIC. Since you are attending this session, I'm pretty sure you know who is APNIC, because they provide IP resources or internet resources, I would say, to their members. And the internet resources are ASN, IPv4, and IPv6, right? So most of the time we'll be talking about IP addresses. That means IPv4 and IPv6 together. So what you have to do is you have to filter out special purpose prefixes. There are a lot of them, right? For example, one of the special purpose IPv4 prefix is RFC 19. They are covered in RFC 1918, right? So IANA allocates prefixes to RIRs, and RIRs ultimately allocates it to LIR, which is local internet registries or their members, right? So if the prefix is not allocated by IANA, they have marked it as reserved for something or for a special purpose or for documentation. It's a good idea to block that prefix from either accepting or announcing it, right? You shouldn't be announcing any of those prefixes. So what you should be filtering, IANA allocated prefix filters, those prefixes which are not even allocated by IANA, right? So there are, if you go to the IANA website and the IPv4 and IPv6 allocation table, you can see how many are marked as reserved, right? 10.0.0.0/8, 192.168, 172, and 100. There are other for documentation purpose. There are some prefixes allocated by the RIR for APNIC as reserved or quarantined. Make sure that you check RIR and see if there are any allocated, unallocated, or specified special prefixes which you shouldn't be using. Prefix fields are created from internet routing registries, right? So IRR, we'll be talking about it. So APNIC is your RIR, but they also provide IRR services, internet routing registry services. And that means they provide you a database where you can look up who this IP belongs to. If you look up 1.1.1.0/24, they will tell you that this IP belongs to APNIC Labs and Cloudflare. So that details is given there. You can look it up. Prefix filtering on the basis of SIDR, we will be talking about that quite shortly. Prefixes that are too specific, of course, anything, other than /24 below, don't accept it or don't announce it. /29, /26, 30s, not at all. Filtering prefixes belonging to a local AS and downstream. IXP LAN prefixes. So these are the things you should be filtering. Now, inbound filtering and outbound filtering. Inbound filtering is you filtering the route coming in from your transit provider, right? And outbound is what you are filtering when you announce to your transit provider. It could be loose, where you can only check on the RIR allocations, or it can be strict, where you verify what exactly you want to receive. So let's talk about what is loose and what is strict. In loose, what you cover, prefixes that are not globally routable. There are some class, if you go back to the IP address classes, class A, class B, class C, then there were other classes, class G, class E as well. So they're not globally routable. Prefixes not allocated by IANA. Now, because it only says IPv6 because IANA has allocated all the IPv4 prefixes. They don't have anything in their bucket anymore. But in the v6 side, yes, they have a lot of. So anything which they have not allocated to RIR, you should filter them. Routes that are too specific, /29, /30. Prefix belong to local AS. If assuming you have private ASN running inside your network or the private network, you shouldn't be announcing that. IXP LAN prefixes and the default route. Unless somebody asks you to give you the default route, don't announce the default route. And of course, not announce the default route to your transit ever, right? And a strict. In a strict manner, what you can do, whatever you have done in the loose, on top of that, it's not like you have to do these 4 things. You have to do these plus these 4. Prefixes that are not globally routable, routes that are too specific, prefix belonging to a local AS, IXVLAN prefixes. In this case, the filters are applied to make sure advertisements strictly conform to what is declared in the routing registry. So if you have declared that I'm going to announce a /24, you filter /24. If you say you're going to announce a /22, you filter /22, and I'm not going to accept anything other than that. No /24 as well. So you can be very strict, or you can be in the middle, right? Outbound filtering, this is from your own network going to the outside world. Prefixes that are not globally routable, routes that are too specific. You can say, well, I don't use these prefixes. I don't use prefixes in my network which are not globally routable. I don't use prefixes which are for documentation purpose, or I don't use 10/8 network in my local network. So why should I do this filtering? Well, you should always do the filtering in first, because most of the filtering happens is you configure and you forget. So what happens is you're gonna filter these prefixes. Let's say you're not using 10.0.0.0/8 in your network today, and you said, because I'm not using it, I'm not going to filter. And what you're doing is you are advertising anything. So you're saying redistribute connected networks into the BGP, right? So anything connected interfaces, their network will be advertised to your transit provider. 2 years later, somebody else comes to your organization that say, oh, 10.0.0.0/8 is not used in the network. I need to do a lab. Let me use that. And they create an interface, and they give that IP to one of the interface, 10.0.0.1/30. What happened all of a sudden, that this address may leak. This address may accidentally go out to the transit provider and can cause problem. So make sure that you filter, even though you're not using those prefixes. Create a habit that you filter everything, right? Now, max prefix filtering. That's another issue. So, I mean, every router has a limit, right? Because a limit to accept number of routes. So it is recommended to configure a limit on the number of routes to be accepted from a peer. Let's say your transit provider said, oh, I'm going to send you 800,000 prefixes. You say, okay, fine. This is the current table size. So I'm going to accept 800,000. But that's a transit. But if you're peering with somebody, and you know that somebody network is only medium size, so they're not going to send you 800,000 routes from their network, right? It should be 1,000, 2,000, 5,000. So you put a limit that I'm going to accept that many prefixes from this peer. So in any case, if someday they accidentally announce more prefixes, then it will shut down the BGP peering, right? So make sure that you do implement that. So I gave you the example of if in the second point it says if you're a transit provider and the current routing table size is 800,000 something, put a limit on, let's say, 900,000. You're not going to receive anything more than that, right? In some cases, your router may die if you receive something more than that. I mean, there is a theoretical limit of 1 million routes before V6 combine, and that limit is going to reach quite soon, or probably it has already reached. So make sure that you are not going to hit that limit. AS path filtering. So the network administrator should accept from customers only 2 byte or 4 byte AS path containing ASN belonging to or authorized to transit through the customer. Let's say because in the AS world as well, there are ASNs which are for either documentation purpose or for private use, or they are just reserved, right? So make sure that you do not accept anything which your customer is allowed to announce. Prefixes sometimes are difficult because there are many, but ASNs are not, because every network has usually one or maximum two or three, but they are a very small number, right? So if, I mean, 68,000 is not a small number, but if you compare it with 800,000 prefixes, it's a small number, right? And you don't actually pair with all 68,000 networks. So you only pair with a handful of them, and they pair with a handful of them. So you can create a list that who are the ASNs you are pairing with and who are their customer, and you only allow them. You can use tools such as BGPQ3 on the basis of AS set, and only allow ASs under that allocation, and nothing more than that. So this is what you do for the AS path filtering, and this is the whole filtering action, right? Now, the number 2 action is anti-spoofing. So I gave you the example of BCP38, which is RFC 2827. So that is network ingress filtering. So what is source address validation? SAV, which is called. That is, check the source IP address of the IP packet. Filter invalid source addresses, filter close to the packet origin as possible, which is called edge. Make sure that you filter, you don't filter it on the transit edge, filter it at the customer edge if you have multiple customers. Filter precisely as possible. If no networks allow IP spoofing, we can ultimately eliminate such kind of attacks, which are quite, I mean, we see it all the time. So most of them, DNS amplification and NTP application, we see that is quite common because of the address spoofing. How you can do that? You can do source address validation by using 2 quite common mechanisms. Number 1 is plain old ACL. You just put a packet filter, permit valid source, and then drop anything else, right? I'm sure you have implemented ACLs in your networks from the beginning, and but you can do that for source address validation. URPF. What is URPF? Well, that's on the next slide. Check incoming packet using routing table. Look up the return path for the source IP address. There are multiple mode for URPF. Loose, strict, feasible, and others. So you can actually do reverse path forwarding check on the basis of from where you are learning the routes. So ACL is easy. Of course, we'll talk about it, but let's talk about URPF first. So what is URPF? It is called unicast reverse path forwarding, right? It checks if an entry exists in the routing table before accepting the packet and forwarding it. So let's see if a packet arrives on your interface, right? And if you have URPF enabled, irrespective if it is loose, strict, or feasible, or VRF, let's say if you have URPF enabled, so your router will check first if the source or address is actually exists in the routing table. If that source address doesn't exist in the routing table, then it means that you don't know about that source address. If your router doesn't know about that source address, it means if that source address arrives into your network, you don't know what to do with it, and that means it will never arrive in your network. So that's how routing works, right? So if you don't know how it's going to arrive, it will never arrive. So it means that is not part of your network. So this is another mechanism of making sure that only verified source addresses can leave your network, right? Remember, this is for traffic leaving your network. So what are the modes? Loose, strict, feasible path, and within a VRF. So let's talk about, more. So source address validation is an active research topic. More RFCs came out on source as a validation quite recently. So make sure that you read about it as well. So it's not only loose and strict. In the past, it was only loose and strict, but we have other options as well. So what loose does, check that an entry exists in the routing table. It looks up and see if there is any entry in the routing table. But you have received packet from a particular interface, right? In a strict mode, it says check that an entry exists in the routing table and the routing points to the receiving interface. You have received a packet from an interface. If you have a strict mode on, it will check if the routing entry is actually pointing to the same interface. If it's not, it will drop it, right? There's another one is feasible path. Check that an entry exists in the routing table or any other route which is not installed or preferred, right? It could be, it's not installed yet, but of course, you know about that route, right? And similarly for VRF, it can be on another VRF because it's creating multiple routing table within the same router, right? It's not just the global routing table of the router, it checks for the other VRF. How do you do that? Simple. I have given two examples, one from Cisco, one for Juniper. You go to the interface, IP verify, unicast, source, reachable, and in Juniper, you only do RPF check. So this is simple. You can implement that, but make sure you test it in your lab before you're doing it because it can create problems. ACL, you are all familiar with them. So what you do, it's towards a provider server, where can you implement it? From the provider towards the provider server, towards infrastructure network. When your URPF cannot be used because of platform limitation. Not every vendor provides URPF, and I think now everybody does that. But still, if there's a vendor which doesn't provide URPF, I don't know any vendor which doesn't provide ACLs. So you can implement ACL as well. And if you do it as close to the customer, as close to the server, as close to your particular infrastructure, then it is not going to impact into your performance of the router, right? So make sure you do it closer to the that device. Third action is coordination. So I can only see one question in the chat. If there are more questions coming up, please start either asking in the Q&A section or in the chat, and we'll try to address them as much as possible, or through other means as well. I mean, I'm still part of the community, so I can reach out to you anyway. Coordination, facilitate global operational communication and coordination between network operators. Why this is important, what it is, and why it's important. So I have taken an example of one of the ISP in Pakistan, Cybernet. Many years ago, I used to work for them. It's coordination is simply looking at your IP, your route, or your ASN, and finding the information to contact the legitimate owner, right? If, for example, you see a prefix, an ASN announcing your prefix accidentally, you should know how to reach out to that ASN, right? So that information is publicly available through APNIC IRR. So APNIC Whois database can provide you this information. It's simple. You query the Whois database through Whois and Whois command, and then you can look it up, all this information. So it gives you a lot of information. What information is necessary? I mean, for anything related to abuse in Asia Pacific APNIC, we have a object called IRT object, right? So this is the IRT object. IRT object should have a active email address, right? And APNIC verifies that email address, if I'm not mistaken, twice every year, because that's per the policy. And in the organizational object, it should have phone number, right? More contact information. So these are the things which should be in your ASN, right? If you, even for myself, I'm not running an ISP, but if you look up the ASN and the IP addresses I own, then you can actually find the email address and the phone number through which you can contact me. It is important for the ISPs to do that, because in case of any problem, remember, we are all connected to each other, right? So even though that ISP is in Pakistan, I'm in Australia, if I need to reach to that network, or somehow they are hijacking one of my prefixes, I should know how to reach out to them. So coordination is important. That is number 3 action. Number 4 action, and which is gaining a lot of momentum quite a lot of these days. And so that global validation has 2 parts, right? Global validation through IRR data and global validation through RPKI data. So let's talk about the global validation through IRR. So we just show you the IRR record, the WHOIS record here, right? So this is the record from the APNIC WHOIS database. So these are the objects which you can actually query in APNIC database. So routing information should be made available on a global scale to facilitate validation, right? So what I can do is I can actually create a prefix list based on what information. So if I'm connected to a, if a customer is connected to me, right, and they have created all the right information in their APNIC WHOIS database, I don't have to ask the customer that how many prefixes you have APNIC has allocated to you. I can ask for their ASN and create a prefix list using the publicly available data. A tool called BGPQ3 is a Python script. You can run that script and it will go check. By default, it goes to the RADB, but I would recommend, if you are creating a prefix filter for a customer who is based in Asia Pacific region and is a member of APNIC, only access the APNIC database, right? So it will access the APNIC database and create a prefix list on the basis of the route objects available on created by the member, right? You can do this for V4 and V6 both. You can create list on the basis of AS set, right? So these are the things you can do by looking at the publicly available data. But me being a member of APNIC, if I don't update the right information in the database, then of course nobody will be able to access it. So the important thing is I have to update that. Being a member, I have to update that information quite regularly and make sure that it is valid all the time. But if my transit provider tell me that I will only accept your prefixes if you create the route object in the APNIC database, then I have to update that information. I don't have any other option, right? So that will force me, being a member of APNIC, to create valid information in the database, because my transit will not going to accept that anyway if I don't do that. So this is important. You have to have global validation. So there are 2 ways, as I said, either IRR or RPKI, providing information through IRR. So the IRR contain information submitted and maintained by the ISP. The member maintains this information. So APNIC doesn't create route objects for you. You have to do it yourself. And IRR can be used by ISP to develop routing plans. As I said, you can use BGPQ3 or any other tool to create prefix filters automatically, right? You don't have to talk to the customer directly and say, well, I'll only access this information if you have updated everything. It will be automatically updated here. But I said one thing. If you use BGPQ3 with default settings, it will access a database called RADB, right? That RADB is not maintained by any of the RIRs. So there are 5 RIRs: Asia Pacific APNIC, Europe it's RIPE-NCC, Africa it's APNIC, Latin America it's LACNIC, and North America is ARIN. So these are the 5 RIRs. But RADB is an independent entity which not only mirrors their database with these 5 RIRs, but they also mirrors many other databases. Other databases like big ISPs, they run their own databases. I mean, if you are a bigger ISP, you can run your own IRR. So, I mean, in Australia, Telstra has its own IRR. NTT, which is a global operator, they have their own IRR. Level 3, they have their own. So RADB, last time I checked, is mirroring more than 30, I guess, databases. And that is the reason why people do not rely on RADB, because it has a lot of invalid data in it, or stale data, because somebody created it at some point but never updated it or never deleted it. You can trust the RIR in that manner because, of course, they are a membership organization. It is their duty to make sure that information is valid and accurate. If a member has left, of course, that information will be released and removed from the database. They have validation processes in place, so they are checking it if the data is valid or not. So things are in place for at least for the RIRs, but not for other independent entities. So make sure that if you are using any tool which are looking for the information from RIR databases, then you point to the particular IRR database, right? But if you are creating a filter for, let's say, Cloudflare exists in many RIRs. In fact, I think in all RIRs. So that would be a challenge. So yes, you have to use RADB in that sense, but make sure that you verify that information. So how do you check a route object? Because remember, I told you about all these objects. The most important one is are 2 of them, route 6 and ASset. So this is a route object, right? So all the prefix filters I was talking about are actually created on the basis of route objects. So let's take an example of 1.1.1.0/24. If you query that one, APNIC whois database will give you this result. It says the route is, which you are asking for, is 1.1.1.0/24. The origin ASN should be. So it is just a database entry, remember. So it is just a database entry. It is telling you the origin AS should be AS13335. That AS belongs to Cloudflare. And description is APNIC research and development and the address of APNIC, right? It is maintained by maintainer AU APNIC GM85-AP. It's a person name, or it could be a department name or somebody who's managing this route, right? So, but the most important thing for you is route and its origin. This is the route, and it should be announced from AS13335. If I look up the RADB for the same route, 1.1.1.0/24, it gives me 2 entries. Because I told you it is mirroring all the RIR databases. So of course it gives me the APNIC entry, but it's also give me another entry. And that entry says the same thing, but it is coming from a different IRR database, right? So the objects are in different location, but it is giving you the exact right information. So at least in this case, it is not giving you a wrong information. So it says the 1.1.1.0/24 should be announced from AS13335, right? Now the second part of the global validation is RPKI. So we discussed about the limitation of the IRR data. So some IRR data cannot be fully trusted. Why it cannot be fully trusted? Because it has accuracy issues. Sometimes it is incomplete. And of course, because there is no direct relationship of the resource holder with RADB or any other service provider who's maintaining an IRR database. So that's why there is no maintenance. So there can be stale objects in RADB which are absolutely wrong. But just because nobody bothered to remove it, it's just there, right? We have to make sure that you rely on the right databases. Not every RIR has an IRR, right? So they sometimes rely on third party. It's, I mean, almost it's you can access every RIR's database in some way or the other, but you have to make sure that you are relying on the correct one. Right. Global validation. The solution for that is the RPKI. The RPKI repository can store information about prefixes originated by your network in the form of route origin authorization. In short, it is called ROA. So you must have heard this new slang word a lot these days, because it is the new in thing in the internet routing table and the internet routing world. ROA, route origin authorization. Remember that one. It's an object. Note that these do not include your customer announcement, but only prefixes that belong to your own ASN. Only the origin ASN is verified, not the path. If you take example here, what this route object is telling you that 1.1.1.0/24 can only be announced from origin AS13335. This is what it is telling you. ROA tells you the same thing, that this route can only be originated from this ASN, right? So you can create multiple ROAs. So you can say this route can be originated from ASN1. This route can be originated from ASN2 as well. Just in case if it is not coming from ASN1, it can be coming from ASN2, but not from ASN3, 4, or any other ASN. Only from these two ASN it can be originated. That's it. So all the regional internet registries like APNIC and in our region, they provide RPKI services to their members. What RPKI is, it ties the IP addresses and ASN to a cryptographic public key. Follows the hierarchy of registries. Registries is RIR gave it to you, so you can actually go up to the ladder and verify the information is correct. Authorize a statement from resource holders. I am the resource holder. I can say ASN X. Only I can create the ROA for my prefixes. APNIC cannot. Nobody else can. I can say that ASN X is authorized to announce my prefixes. But remember, as I said, let's assume I have a prefix which is 1.1. I'm just giving an example. It's not my prefix, but I'm just giving you an example that 1.1.1.1.0/24 is under my administration. I will log into my APNIC portal and I can say 1.1.1.1.0/24 can be announced by me and also by Cloudflare. And I signed it cryptographically. And nobody else can announce it. If somebody else announces it, that route should become invalid. So security framework for verifying the association between resource holder and the internet resources. It is a very easy and scalable solution. Attaches a certificate to network resources upon request that lists all resources. So we just, last week I did a webinar with George Michelson trying to address the issues of RPKI and trying to understand how it works. And we were talking about all these in detail. It is just a combination of AS IP address and the origin AS, right? And how does it work? So you actually do not change anything in the BGP, right? but you give BGP another method to verify if the prefixes it is learning are valid or not. So your router talks to a software called relying party software, or a validator in short. That validator talks to all the 5 RIRs and get all the information, right? So all the RIRs, so the organization which are giving the IP addresses or the resources to their members are the legitimate place to figure out who is the rightful owner. So that information is only available to IRR. So relying party software gets that information, and then through a protocol called RTR, that information is passed on to the router. I mean, RPKI will be discussed in detail in the next webinar which APNIC is conducting, so I don't want to go into the detail, but I'm just giving you how this works. And the router magically find out if the route is valid, if the route is invalid, and it is unknown or not found. It is not found because there was no entry in the database. It was invalid because there was a mismatch, because there was an entry in the database which doesn't match with the announcement you are hearing from the internet. It is valid because there is an entry in the RIR database, and the announcement you are getting from the internet are same. So this is valid. And this is the entry, and this is how it looks like, right? So you can you can go to the this website. It's a portal running RIPE-NCC validator. You can look up this information in a JSON file, and you can parse it accordingly. So that information is available as well. That's all public. There are multiple relying party software. Again, in the other webinar which Tashi will be conducting, he will talk about this in detail. So these are the 4 actions which MANRS is talking about to implement, right? And we believe strongly that if you implement these actions, you can actually secure the internet routing table. And that was the whole punchline of today's session. Let's secure the internet routing table, or the routing for everybody, right? So we have comprehensive test when somebody applies for that to join this initiative. We test their announcement. We look up their information from historical information. We have a portal called Observatory, observatory.manrs.org. Some portion of it is publicly available. You can look up some information about your ASN and find out if you're part of any hijack or leak or bogon announcement or not. So join us and be part of the secure-minded community. And if you want to learn more that how you can implement these actions, there is actually a tutorial on the APNIC Academy, and there is also a guide available on manrs.org website. And the training module I was talking about is this one. You can actually do that as well. So this is all from my end. This is the final say. The good we secure for ourselves is precarious and uncertain until it is secured for all of us. So as I said, if I would, I mean, from the MANRS project team, we would like all the 68,000 networks to join this initiative, but it would be great to have at least a big chunk of it. From the Asia Pacific, we don't have that many. So if you're part of an ISP, if you're part of an enterprise, if you are an administrator who's managing a network, an ASN, then you can join this initiative. So we'd like you to be part of it and be part of the secure-minded community. That's all from my end, and I will look at the Q&As and how that works. Anush, if you want to take that one, or I start looking at the Q&A.
Hi, Aftab, if you can just have a look at the Q&A. I'm trying to get everybody to post all their questions into the Q&A.
All right. Right. So I'll try to do one by one. Okay, this long one. For route leak, how would you identify that a route leak is happening? What systems can we use for this? Looking Glass or any website we can use to check? So as I said, the service, the first service we used to use a lot was called BGPMon, bgpmon.com. That service used to provide services. It's a paid service which is now bought by Cisco. Most of the services are paid services, but there is a open source tool called BGP Alerter. You can use that tool as well. It will tell you if there is a shift in the routing announcement. So you can create alerts for yourself. It will give you the details. And yeah, so there are certain things which you can do for sure. Right. So another question is, I look up in the MANRS observatory, then I saw 60% of anti spoofing. Please explain. Okay, so that's yeah. So 60%. I mean, that will be so that 60% says that we don't have information of that ASN. That's why it is 60%. That will be fixed, and it will show the actual number. If we don't have any information, it will show you 0%. But that doesn't mean that you are spoofing. It means we don't have information. So if you go to because we take the data from Kaida Spoofer project, if you go to the Spoofer project website, you can put up your ASN, and you see there is no result from there. If the result is there, then it should be it should replicate on observatory as well. It takes, I mean, there's a delay, but of course it will show up on the observatory. 60% is not actual. Is not the actual number. It just show that we don't have the right information. So what was the Cisco website for hijack and route leaking monitor? It is called bgpstream.com. The link is available on my website. So that is the bgpstream.com is still not Cisco. It is still the private entity, I guess, so far. I mean, it's the but of course the whole service is now owned by Cisco. In what kind of condition we can receive more routes, which is greater than global routing table? In BGP behavior, it will drop if the prefix in the routing table. Okay, in most cases, what happens is, you must have heard a product called BGP optimizers, right? So BGP optimizer, what they do is they receive a route from a net, and they split it into multiple smaller routes, right? So if you receive a /22, they'll split into 4/24 because of traffic engineering. And what happened in the past a couple of times is those routes were leaked into the global routing table. So you can imagine that on top of the /22, all of a sudden you are receiving 4/24s. And it is not just happening with one network, it is happening with thousands of networks. And all of a sudden your routing table size is hitting 1 million. The moment it says million, your router will just collapse, right? And usually when the memory issues, the router faces a memory issue, it doesn't just tell you that, okay, my memory is out. It will act quite in a strange way. So it can drop BGP session, it can drop thousands of routes from the table, or it can do something different. So yeah, it's always good to have a limit on that one. In case my ASN one IP is victim for any DDoS attack, every time we move to cloud mitigation is not very convenient solution. What kind of basic parameter we need to set up to drop DDoS attack? Okay, the one thing, just remember, so the anti-spoofing I was talking about, it will protect the whole internet from your network. it will not protect you from the whole internet. You can still be part of, you still be attacked from the internet, even if you implement anti-spoofing. So yes, there's only few things you can do to mitigate yourself from DDoS. Of course, the quite easiest way is to do RTBH, which is remote triggered black holing, but that actually serves the purpose. If one of your IP is under DDoS attack and you take it offline, that was they were trying to do. So you serve that purpose. So for that, there are things like traffic scrubbing, which can help you do that, but of course that are expensive. So yeah, it's a you can do only few things to protect yourself from DDoS. Otherwise, you have to rely on third parties. Can you tell again how can we do AS path filtering? I mean, there are multiple things on that one. Number one is if you know that you are connecting to an AS, right? Make sure, and that AS doesn't have any customer. Make sure you put a regex filter saying that this AS cannot announce anybody else from their behind, right? And if you know that they have, let's assume 10 ASs, that ISP has 10 AS behind them, you create a regex saying only these ASNs can come behind this ASN, nothing more than that, right? So that's why you have AS set. That can automatically update that. You don't have to ask your peer or for that information all the time. They have to update it to the database. So that can be done. Another technique is called peer locking. I mean, I have never implemented it myself, but it's very common in the big tier 1 or tier 2 service provider. They peer lock each other. So that, you look up peer locking and you'll find that information quite, there's a document available. So search for the peer locking. So I hope you understand the AS part. Now, so we only got default route and BGP from our ISP. So is my ISP will be responsible for IPI implementation? No. As I said, so there are two parts. One part is creating a ROA. You are only responsible for creating ROAs, not your ISP. But what you can do is, but you cannot, because you're only receiving default route, you cannot implement route origin validation. You cannot validate the routing table. You can, because you're only receiving the default route. But the world can, I can validate you. So make sure you create ROAs. But of course, you cannot do validation on your part. So on the global validation part, there are two things: update the right information and validate it. For you, update the right information, and those who are validating it, organization like NTT, AT&T, CCOM, they are validating that information. So at least nobody else can hijack your prefix. So make sure that you create ROAs. Some prefixes we rent from other than announced under our ASN. So we also need to verify those rental prefixes as well. So if you're renting it, then you are not, nobody is the owner. APNIC only give you so you are the custodian. So if you're renting it from somebody, they are the custodian or they are the administrator of those resources. So they should have access to my APNIC portal. They should create a ROA with that prefix or route you are renting from them and under your ASN. Okay. So if let's say you are renting a prefix, for example, 192.168.0/24, and your AS is 1234, they will create a ROA saying the route is 192.168.0.0/24 and your AS is 1234, and they can create it for you. Only the prefix holder can create ROA, but they can assign any ASN. So they can assign your ASN, but they can create ROA for you. So if you're renting from them, only they can create a ROA. So we are. So okay, I only monitor a business network. It seems like this information is relevant for ISP operator. What can I do? No, it's not for ISP. As I said, it is also for the enterprise, right? I understand probably you are only getting resources from your ISP, right? So IP addresses are coming from your ISP, and of course you're not using, probably not using ASN, or if you're using private ASN or allocated by the ISP itself. But what you can do is you can make sure that you tell your ISP to update your record in their WHOIS database. Number one, you can still implement anti-spoofing. Number two, these are the things you can do at least. If you are running BGP with your ISP, you can still do filtering. They can accidentally give you a lot of routes which you cannot handle. So there are things which you can do as well. So don't just assume that just because you are a business network operator and this is for ISP. No, it is for the network operators. The heading says network operators, and you are a network. So make sure you pick and choose what things you can implement in your network. Right. What can I do for DDoS attack? I'm suffering for last 2 months. Well, I try to answer that one. If you are a victim of a DDoS, it's only few things which you can do. If you're running a BGP, well, actually, you can talk to your operators and ask for the communities. Let's say if the attack is coming from outside your country, what you can do is you can limit that IP to be accessible to only within the country. Let's say if the attack is coming from US and I'm in Australia, I can talk to my service provider and say, only announce this prefix to Australia. So for US, that IP is unreachable, but for Australia, that IP is still reachable. I can take that IP offline to avoid my network to be congested, but there are only few things which I can do. The most normal thing these days is scrubbing services. There are ISPs or the service provider which provide you scrubbing services, which means they can remove all the DDoS attack from the legitimate traffic and then only give you the legitimate traffic. But that has a cost, of course. We are having problem for that now. Validation is not valid. Customers in the range having trouble to access some destination. Why? Okay. Yes. So because, as I said, some of the network operators are actually dropping invalid routes. So if your customer or your ISP has invalid ROAs, route origin authorizations, that make sure that you actually create valid ROAs. Otherwise, you will not be able to access the whole internet, because service providers like NTT, Telia, ATT, CCOM, these are big tier 1 telecom operators. They are filtering invalids. If they are filtering invalids, it means you are only able to access half of the internet, not the full of the internet. So you make sure that you have valid route objects. And if you need to understand how you do that, make sure you attend the RPCAB webinar. Probably it's happening next week with the APNIC. So that's all from the Q&A, I guess. DDoS attack happened on point-to-point IPs, peer-to-peer. Is there any solution? I mean, I gave you the information about DDoS. That is all you can do about that. That is the problem. I mean, you can only protect to a limit. For anything else, you have to rely on other side. Right. So that's all on the Q&A. If there is anything else.
Aftab, there is one more question. It was on the chat. What ICX can you do to mitigate DDoS from ICX end?
Okay, I do not understand what ICX means. What is ICX? If you can help me understand that. What is an ICX? Ishak Lahi, if you can tell me what is an ICX, that would be great. I mean, it's a term I am not familiar with. So do we know which ISP routers have implemented RPKI to filter the invalid ROA? Well, that's an interesting question. Thank you, Chingheng, for asking that. So quite recently, our friends at Cloudflare announces a website called Is BGP Safe Yet? So what you do is you go onto that website and check if your service provider is actually filtering the invalid ROAS. And that gives you an idea that how many ISPs are actually filtering invalid ROAS. But still, the list is not aggressively available somewhere, where you can see that these are the ISPs which are filtering the invalids. We know few big operators such as I said, NTT is doing it, ATT is doing it. There is CCOM, but they are not filtering the North American routes. Telia in Europe, and there are many small operators, and a lot of internet exchanges actually dropping invalids. So the list is very long in the internet exchange arena, but there is no extensive list of ISPs which provides you the detail that these are the ISPs which are dropping the invalids. No, but it's a good point. Let me talk to APNIC and do a survey, at least for the Asia Pacific, to find out who is doing it. I have a problem of mail delivery due to more mail queue from invalid address. How can we use routing protocol to restrict this? If you are not accepting any invalid address coming into your network, I don't think so that it will create a problem for you. But I need to understand more what your problem is. I think what I understand, if you stop in accepting invalid prefixes coming into your network, that problem should be resolved. Next is, if my only ISP filtering invalid routes by RPKI, do I need to implement RPKI in my network? Yes, do not rely on your ISP all the time, right? If they stop doing the filtering tomorrow, so you should be doing it for yourself. Make sure that you filter the invalids if you can, and make sure that you create the right ROAS for your own allocations. All right, so we don't have any Q&A. I'm just have a look. What is ICX? Internet Connectivity Exchange. No, RPKI. So the RPKI repository is accessed via Whois. If I'm just interested, is it easy to look up via Whois or RIPE-STAT? Actually, no, you cannot access it through Whois. So you can do it through well, I wish there was an easiest way to do it, but you can do it through relying party software. There are multiple relying party software called validators. So one is from RIPE NCC called Validator itself. One is from NLNet Labs called Routinator, Cloudflare Octo RPKI, Dragon Labs, and few others. So you can, another one called Ford, FORD. You can install the relying party software, and then those software give you a option to create CSVs of those ROAS, right? So you can actually create a CSV files of those ROAS and look up what is there. So no, simple answer for no, you cannot use Whois. But there is one service. So IRRD4, the updated version of the IRR software, actually has this option, and it will tell you that if this route object has a valid row or not. So in that manner, you can actually verify, but you cannot just simply check if the ROA exists for this particular route through Whois. But you can Whois the IRD4. I think entity is running the IRD4. I don't exactly remember their URL, but if you look up the IRD4, then you'll find out who's running it, and you can actually look up if that route is verified through ROA as well. And if I can just type in here whois.bgpmon.com. If you do whois for this, then it will tell you that if this ROA has a valid route object or not. Any other? So while I was talking, I did, sorry, I should do. So I should have typed it here. So it's bgp, whois.bgpmon.com. So you can do whois for this one. I just looked up 1.1.1.0/24, and it will tell you that RPKI status is ROA validation successful. So that information is available. So yes, you can do that through whois, but not you cannot just query the RPKI databases in that manner. So these IRR solutions are actually accessing the RPKI and giving the information. So at this point, I will stop sharing, and if you have any other question, comment, concern, if not, then I'll hand it over to APNIC Academy team.
We've sort of gone a little bit over time as well, but I don't think there's any more questions. I think we can end the session now.
All right. Thank you so much, everyone, for joining the session. And if you want to reach out to me, my email address is siddiqui@isoc.org. And it's available. The email address is also available in the slide deck, which APNIC will provide you after this session as well. So happy to talk to you again. Thank you so much for your time. Thank you, APNIC, for arranging this session.
Thank you, Aftab.
Thank you.
And thank you, everybody.
Good afternoon, goodbye, good evening.